So much of what we were doing yesterday seemed kind of silly because they asked us to tell them why triangles were similar, and we only had one tool in our arsenal. We only had one tool in our toolbox. That was angle-angle similarity. So this is already in your notes. We talked about it in section 8.2. Today we're going to add two more tools to your arsenal in proving triangles are similar. Okay? So angle-angle similarity is one. If we can get two pairs of corresponding angles congruent, then those two triangles will be similar. Today we're going to talk about side-angle-side similarity and side-side-side similarity. This should sound familiar from when we were proving triangles congruent. When we proved triangles congruent, we could use side-side-side, side-angle-side, angle-side-angle, angle-angle-side, and hypotenuse leg. To prove triangles are similar, we have angle-angle, and then we also have side-angle-side. Side-angle-side similarity tells us that if two sides of one triangle are proportional to the corresponding sides of another triangle, and the angle between them is congruent, those two triangles are similar. If two sides of one triangle are proportional to two sides of another, and the included angle of those two triangles are congruent, then those triangles will be similar. Key word, included. Angle that's in between the given sides. Can't be just any angle, has to be the included angle. So let's see if these two triangles are similar. We have a side, an angle in between it, and another side, with a side, an angle in between, and another side. So are we writing our proportions big to small triangle or small to big? Big to small. Okay, if we decide we're going with big to small, then we have to start out with our big triangle. Okay? Which of those two sides do you want to use first? 12. Okay? 12 is the smaller one. This is the little brother of these two sides. Okay? Which one's the little brother of these two? 3. So you have to put the 12 over 3. Okay? We want to see if that proportion is equal to, what's the big brother of this triangle? 16. Big brother of big triangle going on top. What's the big brother of the little triangle? 4. It's going on the bottom. Now I think why some of you struggle with these proportions is there's so many different ways to show that these are equivalent. You can reduce, you can divide and get a decimal in your calculator, you can cross multiply. They all get to the same result. You choose what works best for you, which one you like the best. Okay? So which do you prefer? Cross multiply. Let's cross multiply. Let's see if 12 times 4, is that going to be equal to 3 times 16? Absolutely. 48 equals 48. So these are similar by side angle, side similarity. Okay. Yep. You could also reduce them and say this has a 3 in common, so 4. This has a 4 in common, so 4. 4 equals 4. It works. Okay. Had we written them the other way, we would have gotten 1/4, 1/4, 0.25, 0.25. So there's so many ways that you can do this, and I think that's what can be confusing. The math isn't hard, just there's lots of options. All right, so here's our second example, our second tool. Okay, Side, side, side similarity. Okay, lots of S's. It says that if the corresponding sides of both triangles are proportional, then we can say the two triangles are similar. So if the corresponding sides of two triangles are proportional, the triangles will be similar. Notice we have no angle measures up there. All we have are sides. So I think of Goldilocks and the three bears here. Okay? If I want to show that these are similar, I need to look for Papa Bear, Mama Bear, and Baby Bear. So first of all, are we using hot pink over purple or purple over hot pink? Big over small, hot pink over purple, whichever way you want to think of it. Okay? So, in the big triangle, which one's Papa Bear? 14.25, is that the biggest one? 18 is the biggest. So, 18. Okay, that's the Papa Bear of the big triangle. Where's the Papa Bear of the purple? 6. Set that equal to, where's Mama Bear? 14.25. What's Mama Bear of the purple one? 4.75. Where's Baby Bear? 9.6. What's Baby Bear of the little one? 3.2. Okay, so we've added a new dimension. Not only are we saying you have to revisit that same triangle for your numerators each time, but we have to make sure that we get them ordered appropriately. Smallest, medium, large, large, medium, small, large, small, middle, and between, you choose. Okay, so there's so many ways that we can set these up. All right, so we need to check and make sure that we actually have equivalent statements. I think the easiest way to do this is to simply divide in your calculator and get to see if you get the same decimal all 3 times. So when we take 18 divided by 6, we get 3. When we take 4.25, 14.25, 14 and 25 hundredths divided by 4 and 75 hundredths, 3. 9.6 divided by 3.2, 3. 3 equals 3 equals 3. They all have that same scale factor. So these guys are similar. Okay? So when they say write a similarity statement or what have you, you have to know the letters. We don't have them here. But we can see that they all reduce to the same thing. Okay? So far, so good? All right, next slide. Here we go. I think I skipped one. There we go. So we want to figure out which of these three triangles are similar. Which sides are proportional. Okay? So we have a big, medium, and small triangle, don't we? Okay? So which ones do we want to start with first? Big. Okay, so I'm going to make my big one, give some blue color for my big one, and I'm going to put red in my middle-sized one. It doesn't look the same, right? But we don't know if the projector's distorting it or if it's truly something wrong. Okay, so we suspect that these two do not whatsoever relate to one another. Let's verify. Okay, so if we say 20 over, what would be the equivalent in this one if it was going to work? 12, because 12 is the smaller of the two, right? Okay, so now we want to check. Does 20 over 12 equal 30 over 16? So cross multiply, do we get the same result? No, because 320 not equal to 360, right? So you're right. Your instincts were absolutely right. Okay? So we know blue and red do not go together. So let's check out which one do you suspect does? Okay, so big and small. So let's set up the proportions. Okay, if we're saying blue, the big one, we're going to have a 20 and a 30 on top. And with the purple, we will have what goes under the 20? 8, what goes under the 30? Okay, now we check. We cross multiply. What do we get? Dividing them out, you get 2.5 equals 2.5. We cross multiply, we get 240 equals 240. It all works. That's just like some of the problems, the very first problems you'll see. Good. That is good. I like to hear easy. Okay? Yep, that's exactly like the homework. Here's another example. Okay? This one looks more difficult. It's not much. Okay? Now they're saying, tell me what value x has to be to make these similar. Okay? So, are they oriented the same way? Yes. So we can start with our biggest side on our big triangle. Say 30 over x minus 5 is equal to, and let's look at something we know. We know both of these, don't we? Okay, 15 over 3. Cross multiply. Be careful here. Yep, we have to take the 15x minus whatever 15 times 5 is. And that's what, 75? Because 15 has to be distributed to both of those. Add 75 to both sides. And then divide by 15. Okay? The key here was to make sure that you pick two that you know. We could have set up this other proportion. When we do that, we'll still get the same result. Okay? All right, last example. I believe there might be one more. Okay? Hard to see, I apologize. I shouldn't have made this darker. I should have used white font. 75 degrees. 75 degrees. So we have two angles. Think about flipping it, right? Okay. Can we decide that these two are similar? Why not? We don't have the included angle, right? Okay. The minute you notice, because we only have 3 tools, angle, angle, side, angle, side, that angle has to be between, and side, side, side. Once you notice that here are my 2 sides and this should have been the included angle, if I don't know anything about that angle, I can't prove anything similar. So don't waste your time setting up proportions. Okay? Has to be the included angle. Okay? All right, last example, the last type of problem that you'll see is something like this. They like to embed them. Okay? So think about this being a small triangle and a big triangle. Okay? Yes. LP would have to be proportional to MN if that was going to be the case. Yep. So we only have sides, right? We don't have a third side, do we? But do we have the included angle? Yeah, it's congruent to itself. So K is congruent to itself. Okay? So now all we have to do is make sure those sides are proportional. So how long was KL? 8. How long is KM? 10. How long is KP? And how long is KN? So let's make sure the proportions work out. Okay? Small to big, big to small, doesn't matter as long as we're consistent. Yep, see if 12 over 15 is equal to 8 over 10. This reduces to 0.8. What's 12 divided by 15? 0.8. 0.8 equals 0.8, so yes. By side, angle, side, similarity. Okay? Those are the kinds of problems you'll see today. All right, let me get you to your assignment. Page 441, it's also written on the board. 3 through 11 and 13 through 20. Right there.